Okay, so then let's take our original drawing and let's note some things about this. So ABC is the pre-image. Okay. A prime, B prime, C prime is an image after a reduction. Okay, so you'll notice that the reduction makes the image go closer to the center of dilation. Notice it's closer to the center of dilation than the original image. Okay. And then A double prime, B double prime, C double prime is an image after an enlargement. So again, if you make the image bigger, it's just going to be further away from the center of dilation. Okay, and that's just how dilation works in terms of the center of dilation. So this is where it is compared to the pre-image, whether it's going to be closer or further away from the center of dilation. Okay. All right, so then what I'm going to do is now we're going to find scale factors. So I'm going to draw an example. Okay, for this example, I'm using line segment AB, and I have dilated it to line segment A prime, B prime. So I want to find the scale factor. So there are some pieces of information that I'm given. I am given that this whole length from D to A prime is 12 inches. And then I'm given that this shorter length right here from D to A is 8 inches. Okay, so I'm supposed to find the scale factor. So to find the scale factor, To find the scale factor, I compare corresponding parts of my images. So if I'm comparing these two things, I want to compare the corresponding parts of the image length divided by the pre-image length. Okay. So whenever you find scale factor, you start with the image length divided by the pre-image length. And I'm going to remind you that the image is the one that happens after the dilation, and the pre-image is what you start with. Okay. So then the image length from D to A prime is 12. And the pre-image length from D to A is 8. Okay, and I can compare these corresponding parts because I know that it's the same, it's proportionally going to be the same, because from D to A prime, this creates one side of a triangle, and from D to A, it creates one side of a similar triangle. Okay, so then my scale factor is 12 over 8, which I can reduce by dividing by 4 to 3 over 2. So my scale factor is 3/2, or 1.5. Okay. And this makes sense because this scale factor is bigger than 1, which means that my image will be bigger, or an enlargement. And I can check my scale factor just to make sure. Okay, let's find another scale factor. Okay, now sometimes you'll be given the length from the center of dilation to each of the pieces, and other times you'll be given the size of each of the pieces. So let's say that this one is 18 and this one's 30. Okay. We'll call it centimeters this time. Now again, if we're trying to find the scale factor, we want to do image length, image divided by the pre-image. So we have to remember that the image is the one that's got the primes on it, so I'm going to put 18 on top. And the pre-image is the one that doesn't, so 18 over 30. Okay. And then 18 over 30 I can reduce by dividing by 3. Oh, I can divide by 6 actually. And then I get 3 over 5. So this time my scale factor is 3/5, or 60%. Okay, I wrote it 2 different ways. And that makes sense because it's less than 100%, because my image is smaller. It's a reduction. All right, that's it.